module, you will learn about vector products. If the product of two vectors, A and B, is a vector, C, then C is called the vector product or cross product of A and B and is read as A cross B. The magnitude of the vector product C is equal to the product of the magnitudes of vectors A and B and the sine of the angle theta between them. When the value of theta changes from 0 to pi by 2, the value of sine theta changes from 0 to 1. And hence, the magnitude of a cross product changes from 0 to AB. What is the direction of vector product C? The direction of vector product C is perpendicular to that of vectors A and B. In other words, vector product C is perpendicular to the plane containing vectors A and B. There are two simple rules to determine the direction of a vector product, namely the right-handed screw rule and the right-hand rule. When a right-handed screw is placed perpendicular to the AB plane with its head on it and rotated from A to B through the smaller angle, then the motion of the screw indicates the direction of the vector product of A and B, that is, C. The other rule is the right-hand rule. Stretch the right-hand palm as shown and place a long vector A perpendicular to the AB plane. If the fingers can curl from A to B through the smaller angle, then the direction of the thumb indicates the direction of the vector product of A and B. Now let us study some properties of vector products. The vector product of two vectors is not commutative. That is, A cross B is not equal to B cross A. Although the magnitudes of A cross B and B cross A are equal. They are opposite in direction. However, A cross B is equal to minus of B cross A. Vector product is distributive with respect to vector addition. Consider three vectors A, B, and C as shown. Let's construct vector B plus C and draw the vector product A cross B plus C. Next, let's draw the vector product A cross B and A cross C. Then draw a vector A cross B plus A cross C. This vector coincides with the vector A cross B plus C. Hence, the vector product is distributive with respect to addition. The vector product does not change its sign under reflection. That is, if we replace A with minus A and B with minus B, there will be no change in the sign of A cross B. What is the vector product of two identical vectors, say A and A? It is equal to 0, because for theta is equal to 0, sine theta is equal to 0. If we consider unit vectors I, j, and k along the three given axes, then I cross I is equal to 0. Similarly, j cross j and k cross k are also equal to 0. The vector product of I and j is equal to the product of the magnitudes of I and j and the sine of the angle between them, which is 90 degrees. The magnitude of I cross j is equal to 1, since sine 90 is 1. The direction of the vector product I cross j is along the positive z-axis. Therefore, I cross j is equal to k. Similarly, we can prove the relationship between other unit vectors and their vector products. That is, j cross k is equal to I. K cross I is equal to j. J cross I is equal to minus k. K cross j is equal to minus I. And I cross k is equal to minus j. If the two given vectors, A and B, are expressed in terms of unit vectors I, j and k as shown, then the vector product of A and B is A cross B is equal to AXI plus AYJ plus AZK whole multiplied by BXI plus BYJ plus BZK. Upon solving and simplifying, we get A cross B is equal to AYBZ minus AZBY whole multiplied by I plus AZBX minus AXBZ whole multiplied by J plus AXBY minus AYBX whole multiplied by K. In determinant form, a vector product can be represented as shown. You have now reached the end of this module. In this module, you learned that if the product of two vectors A and B is a vector C, then C is called the vector product or cross product of A and B. The magnitude of a vector product is given by C is equal to A, B sine theta, where theta is equal to angle between vector A and B. Direction of a vector product can be determined using right-handed screw rule, right-hand rule. Properties of vector products: not commutative, distributive with respect to vector addition, does not change its sign under reflection.